Hello community! Welcome to the third video on SetFit, where we apply SBERT Text classification. Now here in this third video, after I showed you in the first video the theory of SetFit, in the second video I showed you the code of SetFit, now we want to have an hyperparameter optimization of SetFit. So this means we want to have some code that the SetFit system optimizes itself for its parameter. So what are the best parameters for our SetFit system? Now, today we're going to find out how we code that the system optimizes itself. So here we go. At first, we have to install SetFit, clear. But then we also have a hyperparameter optimization. And the people here used Autotune. Now, you might find what is Autotune. Autotune here, very easy if you go to their website, is an open source hyperparameter optimization framework to automate hyperparameter search, or in simple, optimize your optimization. So let the machine optimize itself. Beautiful. So what we do, first step, we load SetFit and we load Autotune. Oh yeah, we have to connect maybe a runtime first. Hey, welcome. Yes, we have a GPU, so great. Initializing, come on, buddy. Connected. Do we still have a GPU? Just to make sure. Yes, beautiful, we have a GPU. So here we go. We load SetFit, everything we need from SetFit, and then Autotune. Beautiful, beautiful, beautiful. Everything satisfied, already satisfied, installed, downloading, beautiful. Okay, all dependencies, yes. Sentence transformer are built, yep. Everything tokenizer, multi-process, Hugging Face hub, yes, yes, yes. So what do we need? Now, a short demo. This is not what we're going to execute, but I show you the backbone of the code that we're going to use. So you see step by step on a simple demo, and then we jump into pure code and we apply the code. So here we go. We installed everything beautifully. And then we have two main functions you should be aware of. The first function is simple. Because the system runs itself, you have to have a model that is defined, that the machine can start itself, can start a model automatically. So this is how you define what the model should look like. And in the second function, you define, hey, this is my set of hyperparameter search in the hyperparameter search space. Here I define my function that I want that you change. I want that you start for parameter 1 at, I don't know, in a certain interval from 0, and you go to the end of the interval 22. So two functions we need to define, the model initiation and the hyperparameter optimization space. Beautiful. So what we do? Well, easy. We import our SetFit model and then we define simply the automated model. And as you can see here, I have two parameters, the maximum iteration and a specific solver for the optimization problem. Just to have an idea what is in those functions. And then what we say, as you know from my video on coding SetFit, we said from pre-trained, we take from Hugging Face a pre-trained SBERT model and we define A, and there are our parameters. Beautiful. So now we have the model, but what are our parameters that we want to train the model on? Now here you have to know a class command from Autotune, and it is simple, a trial command. So what it is? A trial is a process of evaluating an objective function. So let's see, we have here trial.suggest integer. So we have the name of the integer. We have for the interval the low value, the high value, and then even a step value. So for a specific value of an integer parameter, you please go from the low value to the high value and take this step function with you. Or if you have a categorical parameter, you say, okay, this is the name and these are my choices, and you provide a list of choices to the system. Now that we know this, beautiful, we can go on to our hyperparameter optimization space, where we define the training parameters. We decide we want that the system trains itself automatically. So you know this. It's the learning rate. This is a typical gradient descent learning rate. You know from machine learning the number of epochs. You say, okay, it's an integer. Well, of course. And you go from 1 to 5. The batch size. How important is the batch size? You say, hey, experiment with batch size 4, 8, 16, 32, 64. Run a trial, show me how important is batch size. Now, seed, yeah, you can maybe define your seed if you want to have reproducibility. Much more important, I think, is the number of iterations. And you can go here categorical, so you take 5, 10, and 20. Play around with it. The number of maximum iteration, and then solver. Now, the solver for a hyperparameter optimization space, if you have never done it before, there are 3 classical types of solver from, I don't know, the 2000s. If you read the classical textbooks, you have, for example, what the solver does is it applies an iterative method for solving nonlinear optimization problems. And if you know a little bit of mathematics, you know the Hessian matrix. It is a square matrix of second-order partial derivatives of a scalar field. It describes, if you know this from topology or from mathematics, the local curvature of a function of many variables. And then we have here, for example, 3 different solver possibilities. The classical one that you know if you study data science, you have your PhD. So you have the conjugate gradient algorithm, and this is for all the methods for minimizing a functional. The conjugate gradient method gives the maximal minimization of 10 steps. And then you have derivatives of this. For example, the limited memory, and this is a beautiful name, Bryden, Fletcher, Goldfarb, Shannon algorithm, or there's a short abbreviation if you want to use it. And there are a lot of possibilities. So please find your possibility. Maybe it is already programmed here in this trial version, and it is available for you. So we use these 3 here, or you do take a subset of it, whatever. So if you want to, if you're not familiar with and you want to have a little bit of a deep dive, short exercise for you. Compare the convergence of the classical gradient descent with an optimal step size and compare this to the conjugate vector for method for minimizing a functional. Have an idea what's going on there. Yes. So if we have defined now, summarize. If you have defined the model that the system should run automatically, and we defined here all our parameters that we want, we decide the model should change step by step, play around all possible iterations. Great. So what we need a data set. You know this from my last video. And we need to set up a SetFit trainer that is provided by the system. Beautiful. And then you simply say, hey, trainer, and this is now the new command, .hyperparameter search. You say you want to maximize it, and you define with this HPO space function all your training parameter you want to have checked out for you. And the number of trials is important, the number of combinations, but careful. If you go with a higher number, it takes hours and hours of time because this system really runs through the complete system. So let it run overnight maybe, or you have a very high performant infrastructure hardware. So after you had this hyperparameter search in the hyperparameter space, you got an optimal set of hyperparameter. And you then say, hey, trainer, now apply my found hyperparameter that are best. And use this, and then you say, as before, trainer, train yourself with this particular set of hyperparameters. So this is all there is to it. This is it. This is the theory of all of it. And the beauty is we are ready to go. So let's do our own example. So as you know, we have here our NumPy. We import our SetFit model, our SetFit trainer. As a loss function, we have the typical classical cosine similarity, nothing special about here. Then we have our data set. As I showed you in my last video, we take a very specific labeled data set from Hugging Face, a multi-labeled data set, and we define our training data set and our evaluation data set. Let's do this. Finished. Yes, running. The number of samples. Yeah. Here, just for demonstration purposes, I go with a real low number, just 8 samples per class for SFit to train on. Why? Because if I run over this lots and lots of time for the hyperparameter optimization, I don't want to spend hours in front of the computer. So I would recommend you go a little bit higher, maybe with 16, but it all depends on your system and the number of samples you have per class available for training the classification head of SetFit. Yes, 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 yes. Beautiful, beautiful, just to have a look at it. So our training data set, we have the features text, violence. These are our character, our parameters from the training data set we downloaded from Hugging Face, and our evaluation data set. Yes, beautiful. So here we go now with the real task. At first we have to define, as I showed you in the last video, a SBERT model, a sentence transformer model that is pre-trained and available for you with all the weights for, let's say, the English language, all ready for you. So we download the complete vocabulary, download the complete weights, we download everything from a pre-trained SBERT sentence transformer model. Great. So we define here, let's call it make model, whatever you want. And then what we want, of course, a multi-label strategy. So we say multi-target strategy, the parameters are a multi-target strategy, and if the parameters are given, beautiful, else, in my last video, I showed you one versus the rest of the world. And then we say, okay, beautiful. So what you do is you say SetFit model from pre-trained, like in my last video. We define here the model ID. This is the sentence transformers. And then, as I already showed you last video, again, we have to define the multi-target strategy that we're going to use here. Multi-class, multi-label, beautiful. Multi-target strategy. So we defined now our model that the system can run automatically. It knows exactly the parameters it needs. Beautiful, beautiful, beautiful. Now, next thing is define the trainer. Now, with the trainer, this is absolutely the same like in my last video. We have now the model initialization. This is our function define model. Just we did it here. Then we have a training data set. We have an evaluation data set if we want to look at the training of the system while executing. Or a loss function for SBERT is the very, very famous cosine similarity loss function. You can optimize the loss function, of course. Now, for demonstration purposes, the number of epoch is just 1, but please don't leave it on 1. Yeah? Number of iteration, also the minimum we can achieve here, just to show you an effect, is 5. And then, yes, we load everything. Yes, I already had a test run, so you see already some results, but let's do it live. Now we load everything down. Our training data set and evaluation data set. Yes, we download everything, download, beautiful. And we have now a SetFit system defined. Now you say, okay, let's train this system. Yes, you are right, but we want that the system finds the best parameter for itself. The system trains itself. So how we do this? We decide to define our hyperparameter search function, our HPO function. And here, just for demonstration purposes, we go with 3 parameters you want to optimize. You want to check what the system says is the best of those 3 parameters. Is it the learning rate? And for the learning rate, you know, learning rate, it start here, go there. Is it the batch size? You say, hey, try batch size 4, 8, 16, 32. And then even if you're really courageous, let's go. And you say, hey, let's check the multi-target strategy. Is it one versus the rest like we had in the last video? Is it a multi-output, a pure multi-label, multi-class? What is it? So you define here, you can say, hey, I want a 4th line with, I don't know, whatever, the number of iterations or whatever. So you define here your parameters. The system should optimize itself. And watch out, the most important parameter should be in your list here. Hey, great, this is it. So we've downloaded everything, yes, 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 and you get the warning. Hey, initializing the classification head with just random weights, and the recommendation here, you should train this model on a downstream task to use it for inference and then predictions. Beautiful, this is exactly what you're gonna do. We have now this, then we define our hyperparameter search function, done, and then we say, okay, now we take our trainer system that we defined, and now we say, okay, dot hyperparameter search. This is not the function where we say, okay, now let's execute this hyperparameter search function on our trainer. And you say, yes, the number of trials is, and this time it was 10. And as you can see, yesterday already I did a training run because it takes quite a lot of time. And I did it once, so I don't have to do it again. This is, if you activate this sequence, this is what you get. So you see here, you have a lot of runs here. Running, training, number 1. Then you have number 2. Then you have number 3, number 4, number 5, number 6, number 7, number 8, number 9, and number 10. So the system goes on, gives you all the parameter, finishes with the learning rate of this, then you have the objective, the hyperparameter, the learning rate, the batch size, what multi-target strategy performed best, and then you can say, and this is now a functionality of Autotune, hey, show me if these are my 10 runs, my 10 and my 10 executions I had, which had the most important effect on the training of the system. And you see here we had 3 parameters we trained the system on: the learning rate, the batch size, and the strategy itself. And you say, so show me what was the most effective parameter for my particular system, for my particular data set. And you see that the learning rate with 88% is really the dominant factor. If you increase the learning rate, you should see the most effect here. But remember, you only had 10 iterations on this, 10 runs on the system. So if you are then really serious, say, I don't know, let's take 100 runs and really be sure that you have you invest here in the compute resources. I know it might be expensive, but let's do it one time and get really a real life experience. What is the most important factor for your system? And then you can go on and optimize it with the parameter. So I'm not going to execute this because this is in the cache. And what you do, as I just showed you, now we have the optimization parameter from the system. And what we do is we say, hey, trainer, now apply those hyperparameters we found, the best hyperparameters. So replace this now with those models that have those parameters. And then, as always, you just say, hey, and now train. And then it goes on and it trains with the perfect size of the hyperparameters. And then it shows you running the training, number of samples, number of epochs is 1, which is crazy, but this is just for demo, yeah? If you do it here in a real life where you have number of epochs, I don't know, 100 or 10 or 100 or whatever. Optimization step tells me, hey, 61 sounds, this is the way to go. Beautiful, and you do it. And then, as I showed you in the last video, I know, again, you have the evaluation of your system, and we defined the evaluation dataset, and the command is simple: evaluate the system, the trainer, and show me now the metrics. And since I had here the number of epochs limited for demo to 1, you know that the result is just 31%, but it's not bad. Come on, if 31% of all samples that were found had all 8 parameters, all 8 labels of our dataset right. If you think about this, and this took just 1 epoch and just 61 steps, this is not bad for such a small little cute system. So here you have it. This is the way how you can code a system that defines its own hyperparameter for an optimal performance of the system you defined, of the SBERT model you've chosen for your data, and the data set that is your specific individual data set that you train the system on. So I think this is very nice. The only negative thing is it takes a long time here to perform all those system optimizations because it has to run over all the system parameters, always run the complete system. So if you make a plan, figure in a lot of time, a lot of financial resources, if you have a paid infrastructure to perform all those different tests, but the end result is beautiful because then you get a set of hyperparameter where you know that your system performs best. So I hope you enjoyed this one. This was about hyperparameter optimization for your SetFit system. I hope you learned a little bit, maybe about solver and nonlinear optimization problems. There's a lot of literature. You can go on for hours and hours of different solver methodologies, but we just we profit here from this Autotune class. But if you have any other system that performs here for hyperparameter optimization, please go with it. This is just the official demonstration from the team of SetFit. They showed us in their demo that they use Autotune. So this is the reason why I showed you this. All the credits of everything go to the team of SetFit. They are the geniuses who came up with this idea, and they coded, implemented this methodology. And this is the reason why I can show you today how to do a hyperparameter optimization for a SetFit model based on SBERT. Beautiful! We achieved it! Congratulations! So, this was it for this video, and I see you in the next one.